What is going on, internet people? We're going to do a quick video on interval notation here. It shouldn't take too long. And then I'll have some practice stuff for you to go over in, I think I've got it in, it's online, so just check online and I'll tell you where to look. But anyways, interval notation. One thing you got to know is we have inequalities represent a range of values, but they're not, I don't know, I don't think they're the most or the simplest way to write a set of values. There's another way that you can write a range of values that's really easy, and it's called interval notation. We have seen, after this, you have seen three different types. Okay, you guys have written a range of values as inequalities, as a number line in a graph, and we're going to learn this thing called interval notation, and it's really easy. You just take all the numbers in the range, and then you put your lowest value on one end and your highest value on the other end, and you say, hey, all the values of interest are from here to here, or whatever. So that's all interval notation is. It's really easy, and so I think this is going to be probably one of the easier assignments all year, but it's a good thing to practice. First thing we're going to do here is we are going to make sure you guys understand how to represent an inequality in all three ways. And I've got this little table made, so hopefully this will help you kind of piece things together. Remember, on a graph, so open circles look like this, closed circles look like this. And when we're doing a graph or a number line, any of the inequalities that have a less than, greater than, so without the equal sign, are represented by open circle, and anything that has an equal sign is represented by a closed circle. Super cool. All right. So that's old information. Well, it turns out anything that is, well, actually, really quickly, I am missing one thing in this chart that I would like to add. It's also true. Let me drag these down really quick. Oops. Okay, it's also true that on a number line, you have to be careful because sometimes there isn't a lowest value, so to speak. The arrow just heads off kind of towards a really large number or a really negative number, and so sometimes we use infinity and negative infinity when we're talking about where numbers are headed. And it turns out that infinity and negative infinity can't be represented by a circle, so it's not super relevant. But when we're talking about interval notation, we do say that negative infinity can be of the lowest value, and it can never be the highest value, but infinity can be the highest value. So anything with an open circle, or anything that is not included, is represented by parentheses, or unattainable to reach. So that would be like if I say I have at least $5 in my wallet, saying at least $5 means $5 is an acceptable value. It's the included value. I could have $5 in my wallet. I could have 20. I could have 1,000. Right? I don't have 1,000. But if I say I have more than $5, the acceptable values go all the way to $5.01, and really, they get ridiculously close to 5, but 5 is not included. So is the endpoint included? When I say more than $5 in my pocket, it is not, right? So we would use, parentheses and open circle if we were to graph that. So this is just a verbal thing saying no, it's not included. And then the last thing that we need to know is, I guess we can do that. If it is included, if the endpoint is included, then we use square brackets. Just like this. All right, so make sure you have this copied down. We're going to reference it pretty frequently. All right, let's graph x is greater than 2. X is greater than 2. I'm going to put 2 in the middle. We'll go 3, 4, 1. Whoops. Can't count apparently. 1, and 0. All right, so I'm just going to grab a color. Let's use purple. How do we graph this? Well, it's got greater than 2. What are the numbers that are bigger than 2? This is greater than, so we use an open circle based on the chart that I just showed you. We shade everything to the right, everything that is bigger than 2. So how do we write this in interval notation? Well, we take a look at what's in purple. We write what is the leftmost thing, right? When I say the low value, I really mean kind of, in this case, on the number line it's leftmost, but it won't always be leftmost in other cases. So the low value, comma, the high value. So my low value here is 2. The low value that's shaded is 2. And the high value is headed off toward infinity. Now we go back to our chart. An open circle is represented by parentheses, and anything that has to do with infinity, you can never reach infinity, just like our solutions never reach 2, but they get really close to 2. So we always just use parentheses. All right, let's do the next one. X is less than or equal to -3. We'll put -3 in the middle. -2, -1, -4, -5. We'll grab a color. How about red? Okay, -3 is our boundary, so we'll put a closed circle on -3, and we're going to shade everything to the left. So let's talk about what's our lowest value. What's our leftmost value? That is -infinity. So we're going to go, our shaded region, our region in red, exists. So the range of values that we're interested in is from -infinity up to -3. Infinity always has parentheses. Since this is a closed circle, we use a bracket. And that's really the whole thing, right? It's pretty straightforward. Pretty straightforward. All right, I'm now going to do a compound inequality. I think it's important to note that inequalities exist in kind of 3 categories. The ones at least you're going to be working with interval notation. They either, have a boundary and head one direction. I call those basic inequalities. There's compound inequalities that are and inequalities, and compound inequalities that are or inequalities. We're going to do the and one first. So we'll put a 0 right here, 0, 1, 2, 3, 4, -1, -2. Grabbing the green one. The values that we're interested in are the values that are, let's think about our 2 inequalities. This can really be written as x is greater than or equal to 0. So we're interested in things that are this direction and are also less than 2, which is this direction. Now remember, and means overlap, right? What are the numbers that are bigger than or equal to 0, but also, and they are less than 2? And of course, that region is, they overlap here at this endpoint because that endpoint is included. They don't overlap here because it's not included, but they overlap everywhere in between. This is our answer on a number line. On the interval notation, that is the leftmost value, or the lowest value, 0 up to 2, open circle, parentheses, closed circle, bracket. And our last one, which is our compound or inequality, I'm going to do this kind of quickly. So it goes from -200, oh boy, so there's 0. Let's go 100, -100, -200, -300, and we'll put 200 right here. All right, cool. So we want to graph this. We're looking for things that are less than or equal to -200. Well, that's going to look like this. But they could also be greater than or equal to 50. Well, that's going to be that direction. So then we take those. Or means everything, right? Or means everything. So we take these two, we slam them down onto the axis. Everything that they touch is included. So this way and this way. Okay, so how do we do this with interval notation? Well, you're probably thinking, Mr. Schlegel, we have two intervals here. Yep, they're separated. So we have to talk about this one. We have to talk about this one. So it is, the lower one is from negative infinity up to negative 200 bracket. The second one is from 50 up to infinity parentheses. So when you have two, if you ever have two intervals that you're trying to go join together, you stick a U between them. This stands for union, like marriage, right? Like a union, it's joining them together, sticking together, saying that the numbers of interest are from negative infinity to negative 200, including negative 200. But there's also a second group that we're interested in that is from 50 to infinity, so on and so forth. All right, that's the whole lesson. Hopefully that made sense. You can practice on your work. Okay, later.